Okay, so looking at this one, let's say we just wanted to analyze this and figure out how we could linearize this. So first, is it power exponential? Power is if x is the base, exponential is if x is the exponent. Well, this kind of looks like a square root function, doesn't it? So it's going to be a power one. Now, anytime you want to linearize it, what you're going to need to do is do something to the x or y. You could do it to one or both. So it looks like that when we want to linearize it, we want it to be like this, right? So how can we make it like that? Well, it looks like the y's are being too low, right? So we're going to have, let's just try to do something to the y. What can we do? We can square it, and it will be the same data, but it will be linear. We could have square rooted the x. But anytime you have something like this, that's what you would want to do. Okay, this time it's going to be exponential. It looks like an exponential one, right? It could have also been like that, or it could have been a logarithm. Either way, but this time the y's are being too high, so we need to do the opposite of what it is, which is log of y. And once again, we could have also done to the x, made it we could have done 10 to the x instead, but you would usually think to do that. So there you go. So what if we wanted to figure out what was a better fit? Residual, or the regression, sorry. So it's not focusing, sorry. So basically, how we know is, first thing, if there's a pattern, then we know that's bad. Luckily, for both of these, I know it's kind of hard to see, but there's not really a pattern. Then we could look at the r squared values if given. Remember what the r squareds show? This is the coefficient of determination, and it shows the percent of variation explained by the regression line. So what these are, they're the residual plots. They're kind of just making it horizontal when it would have been like that if it was the regression line, which is basically the line of best fit. So this is really just a line of best fit. But it's saying, r squared is saying what percent of the variation is explained. And basically, if that doesn't make sense, if it's closer to 1, then it's better. This one's closer to 1, so it's better. So it shows not a pattern, right? So it's better because it appears to be a nonlinear relationship between x and y. This isn't a relationship between x